Good morning. Welcome to my YouTube channel. This is Mr. Mringa E. We are going to revise the question on moments which came in 2019 paper 1 GCE. The question goes as follows. The diagram below shows a uniform plank of length 100 centimeters kept in equilibrium by a 3 kg and 1 kg mass placed 10 centimeters and 20 centimeters from each end, respectively. Part A. Number 1. Calculate moments of the 3 kg mass. Number 2. Calculate the weight of the plank. Part B. State one application of this setup. So the first question, they want us to find moments. In the first question, they want us to find moments. So what is moment? Moment is the turning effect of an object. Moment is the turning effect of an object. Or moment is the product of force and its perpendicular distance. It is the product of force and its perpendicular distance. So this is what we are going to use, where moment is calculated in Newton meter. So they want us to calculate the moment which is here. So our SI unit should be Newton meter, but what we have here, we have 3 kg and we have 20 centimeters, which means we need to convert before doing the calculation. So let's convert mass from kg to newtons by applying this formula: weight equal to mass times gravity. So weight equal to mass, we have 3 kg, times gravity, we have 10. So weight equal to 30 kg dot meters per second squared. Now what is the kg dot meters per second squared? This is 30 newtons. So after converting mass into newtons, we have to convert now distance into meters also. So we have distance which is equal to 20 centimeters. So we will say 1 meter is equivalent to 100 centimeters. So this will go. So our distance will be equal to 0.2 meters. Therefore, moment equal to force times the perpendicular distance. From force we have 30 newtons times 0.2. So if we multiply the two, we are getting 6 Newton meter as our moment. Okay, so we go to next question, which is the weight of the plank. Weight of the plank. I want you to pay much attention on this one. So when they ask you to find the weight of the plank, first thing first, you should identify the point where all the forces are acting, which is the center of gravity or center of mass. Since this plank, it has a length of 100 centimeters, so we expect to have the center of mass or center of gravity. So we expect to have the center of mass or center of gravity at 50. That's where this Planck can balance. So we have 10 plus 20, which is 30. So our 50 is likely to be somewhere here. That's the force we are looking for, the weight of the Planck. Okay. So what we are going to do here, since we have converted this one into newtons, which is 30 newtons, we need also to convert this one, which is going to be 10 newtons. So we are going to label this force as force 1. Then this will be our force 2. Then we have force 3. So we are going to apply principle of moment here. We are going to apply principle of moment. So force 1, its corresponding distance will be this one. Then force 2, its corresponding distance will be the difference from pivot up to the applied force. And this distance is going to be, since the pivot it is at 30 and our weight is at 50, so this one will be 20. It is distance 2. Okay. So F3, its corresponding distance is going to be 50, which is going to be D3. Okay. So principle of moment states that the sum of clockwise moment is equal to the sum of anticlockwise moment for the body to be in equilibrium. So we need to identify the forces that are moving in the counterclockwise. So we have only one, F1, it is moving in the anticlockwise moment. Then we have F2 and F3 that are moving in the clockwise moments. So if we were to drag the two forces downward, this lever will be in the upward direction like so, which is the clockwise moment. If we were to drag 3 kg or 30 newtons downward, it will rotate like this. Okay. So we are saying anticlockwise moment is equal to clockwise moment. So moment 1 will be equal to moment 2 plus moment 3. We have two forces that are moving in the clockwise direction. But moment, we said, is calculated by FD. So here we'll say F1 times D1 equal to F2 times D2 plus F3 times D3. So F1 we have 30 newtons, D1 we have 20 centimeters. Don't worry on the SI unit. The centimeters will cancel each other. F2 we have weight of the Planck times D2 we have 20 plus F3 we have 10 newtons times D3 we have 50. So 30 times 20 we are getting 600, which is equal to W times 20, it's 20W, plus 10 times 50, it's 500, At this stage, we have to correct the like terms. So we'll say 600 minus 500 equal to 20W. So 600 minus 500, we are getting 100, which is equal to 20W. We divide both sides by 20. So W equal to 5 Newton. So this is the weight of the plank. This is the weight of the plank. Then application of moments. So this is the last question. So as for application, this device is applied in making seesaw. It is also applied there. Moment is applied in making doors. Moment is applied in making bottle openers. Moment is applied in making shovel. So it is applied in many. But for this one, you can say it is applied in making seesaw. Thank you for watching. Don't forget to like my video, to share, so that we educate many. Thank you.